On September 14th, 2015, something happened billions of light years away. Two black holes collided. The collision released more energy in a fraction of a second than all the stars in our galaxy emit over a much longer period. And then, something incredible happened. Scientists on Earth detected it, not with a telescope, not with a camera, but with something so sensitive it could detect a disturbance in the fabric of space itself. The signal lasted less than a second, but when scientists converted it into an audible frequency, it sounded like this. That tiny sound was the first direct detection of gravitational waves, and it changed our understanding of the universe forever. But here's the strangest part. The sound wasn't actually traveling through space. So, what exactly did scientists detect? You've probably heard that space is completely silent, and technically, that's true. Sound needs a medium to travel through: air, water, or another material. But space is almost a perfect vacuum. So if you were floating between the stars, you wouldn't hear an explosion. You wouldn't hear a spaceship flying past. And you definitely wouldn't hear two black holes colliding. But the universe has another way of communicating: through gravitational waves. When incredibly massive objects accelerate violently, they can create ripples in the fabric of space-time itself. Think of it like throwing a massive stone into a perfectly calm pond. Except instead of water, the thing that's rippling is space and time. And when two black holes spiral toward each other, those ripples can travel across the universe. Imagine two black holes, each one more massive than our sun, orbiting each other at incredible speeds. At first, they're separated by an enormous distance, but they're losing energy. And as they lose energy, they spiral closer and closer. Their orbit gets faster, the gravitational waves become stronger, and the entire system begins accelerating toward one final moment. Then, they collide. And for a fraction of a second, the universe itself rings. The collision happened roughly 1.3 billion years ago, long before humans existed, long before our species even appeared. But the gravitational waves traveled across the universe until they finally reached Earth. On Earth, scientists had built something extraordinary: the Laser Interferometer Gravitational Wave Observatory, LIGO. LIGO uses enormous laser instruments to detect incredibly tiny changes in distance. We're talking about changes so unbelievably small that they are far smaller than the width of a proton. And on September 14th, 2015, LIGO detected something. At first, scientists didn't know what they were looking at. But then they saw the pattern. The signal started low, then rose in frequency, then suddenly stopped. It matched what scientists predicted would happen when two black holes spiral together, merge, and settle into one. The universe had just given us something we've never directly detected before: a gravitational wave. Here's where the story gets really strange. The signal LIGO detected wasn't actually something you could hear with your ears. It was a measurement of how space-time itself had been stretched and squeezed. But the signal had a frequency, and scientists could translate that frequency into the range humans can hear. When they did, they got a sound: a short, rising chirp. The sound was incredibly brief, but that tiny chirp represented something enormous. Two black holes, each with the mass of stars, had spiraled together at unimaginable speeds. And in less than a second, they became one. The final black hole was less massive than the combined mass of the original two. The missing mass had been converted into energy, carried away as gravitational waves. Here's something almost impossible to comprehend. The collision happened approximately 1.3 billion years ago. The gravitational waves began their journey while Earth was still unimaginably different, before humans, before our civilizations, before almost everything we recognize today. The signal crossed billions of light years, and finally, it reached Earth. For less than a second, the distance between parts of our planet changed by an almost incomprehensibly tiny amount, and LIGO noticed. Think about what that means. Something happened on the other side of the universe more than 1 billion years ago, and we built a machine sensitive enough to detect its echo. We didn't see the black holes. We didn't photograph the collision. We detected the movement of space-time itself.
So when people say scientists heard two black holes collide, that's not exactly what happened. There was no sound traveling through empty space, no explosion that someone could hear. Instead, humanity detected something even stranger, a ripple in reality itself. And when we translated that ripple into sound, the universe gave us a chirp. A sound that lasted less than a second, but represented an event that happened more than 1 billion years ago. Two invisible monsters colliding in the darkness, sending a ripple through space-time that crossed the universe until one day it reached us. And for the first time in human history, we weren't just looking at the universe, we were listening to it. And somewhere out there, right now, two more black holes could be spiraling toward each other. And when they finally collide, the universe may chirp again.